Alright, ready? Ready? So first thing in module 2, we are look at problems, pros and cons and problems. All right, so let's take a look at, let's run through all these laws and then practice some of the problems, right? Got here online? Right. So first thing we need to remember, let's say we have n online objects, right? And you want to arrange them, just move them around, you're not choosing, you just want to move them around, use n factorial. Right, so for example, if you have A, B, C, and I want to find the number of arrangements, that's simply 3 factorial. Okay, but suppose now you have similar letters within it. 2 A's, a B, and 3 C's. How do you find the number of arrangements? Well, count it. You have 1, 2, 3, 4, 5, 6. That's 6 factorial over P factorial, Q factorial, R factorial. So basically, how many A's you have? 2 A's. How many B's you have? 1, so you can leave out that, and you have 3 C's. Right? That is the way you obtain the number of arrangements when you have n objects and some of them are like that. Okay, that's just arranging them. But if you have to select now, if you have to select n objects and the order matters, NPR. Select the objects and the order doesn't matter, NCR. So for example, let's say we have A, B, C, D, E, F, right? And I want to determine the number of 3-letter words that I could get from those 6 letters. What you will choose? P or C? NPR or NCR? So I want to choose 3 from the 6. So when you choose it, it's either NCR or NPR. And I want to make 3-letter words. What would it be? P or C? 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 What is it? C? 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 So let's see if it's C or if it's B. Let's say you choose A, B, C. Remember I said different words, yeah? And let's change the order. 2 different words? Yeah. But it's not really a word in the word. Somewhere you will like the word, right? So that's 2 different words. So therefore, order matters. Okay? So if you select A, B, C, and then you select B, C, A, same tree, and it's 2 different words, or based on the condition, you know you're going to use 6, B, 3. Okay with that? As P, or P. Okay, P. So that's the way you figure out if it's C or P. Make a selection, rearrange it, and see if it's a different condition. If it's not, if I just said 3 letters, it don't matter. A, B, C will be the same as B, C. If I said words, then A, B, C is a different word from B, C. Okay, nice. So we have to remember how to arrange and how to select and arrange, right? Then basic probability, we need to remember how to find probability, number in event, number in sample space. Basic laws of probability or probability between 0 and 1 and so on, right? If you have two events, probability of A or B is given by that. Probability of A and B, if they're mutually exclusive, is that. Right? For conditional probability, A given B is A and B, and independent events, A and B independent, that is your common. Probability tree diagram, you don't really see much, but if you see it, your probability tree diagrams, you have to remember from every node, probability sum to 1, right? And this node here is dependent on the first node. This node here is dependent on this one. Okay? So the probability tree diagram is a conditional tree diagram. Okay? Every other branch is dependent on the other. Right? So here's an example, right? Conditional. Right. You do have many questions on it, but let's do them all one time, right? Right, let's do this applied one time. Let's check out 2024, 23. So what we get. No. Right, as I said, now every year probability, yeah, that's the number 3 or number 4. I have a small thing here. Actually, no. I just know, I know I didn't teach it, well, you would have done it already. I just know if you use it like the probability, and just show you what distributions. You see the word that? You see distribution there, right? Or you would see conditions or parameters that you need distributions for, right? All right, 3 out, forget 3. Try that pass. Find each other for following. You can use the formula to define it, right? Right, that's all there. That's 2024. Yeah, you can put it in, but you put the formula. You can do it. Right that pass. When you say no, set up. Oh yeah, try that quick. Oleh nanti lo kena bahas sama kita boleh kita sendiri juga. Nanti lo sudah bahas. Terus apa ni? Aku nak apply itu sama orang kan di Waves. Hah? Pure real bahas. Kalau itu pure, ada dekat web pure tu sendiri. Oh, nah, bila baik nak. Tapi pure. All that get exams take a good form. Real bahas juga apa dia? Aku mana bisa apa pun. Akan minta jangan ada suara. Jadi sulit. Anak harus satu. I'll see. I was like, I can for example, right, independent events. Independent event mean what? Independent event means what? That one doesn't depend on the other, right? Or you write the intersection is equal. Right? A doesn't depend on B. Right? A doesn't depend on B, so you can say the probability of A given B is equal to the probability of A. Right? Or you could say A and B is the probability of A by the probability of B. That work as well. But I like the first one the most in terms of explaining it. Mutually exclusive, real simple, it means that they don't intersect. So the probability of A and B is 0. Right? A and B do not intersect. Conditional probability. Conditional probability is where A is dependent on B. So the probability of A given B is the probability of A and B all over the probability of B. So when you explain it, give the words first. See that A is dependent on B. That's the conditional means. A is dependent on B and is found by them. Right? So in words, the first one, A given A is not dependent on B. Second one, A and B do not intersect. Third one, A is dependent on B. Okay? It just have the definition. Right? No calculations here, right? Part B is chi-squared, I think. Right? That was 2023. Let's change it now. Right? 2022 had none. Two had none, right? So you're 20. What did I reach? Right? I see 21. Hold on. Huh? 2019 have one, right? Who's not 2023? 2019 have one. 2019 is number 3 part 3. Twenty 19 is number 3 part 3. Right? At least 4 men, no men, and then they want to commit, they want a probability here. Right? We'll come to that estimate, right? You all finish all this already? First part? First part? Right, give me some time. I will some time. Finish it? Ten men and 9 women, right? Oh, here on 9, right? Killen. Hey, Killen, you come to class? Right, to determine the number of possible committees that can be chosen if the committee consists of at least 4 men or 6 people, right? There's a 6-person committee. So you have 1, 2, 3, 4, 5, 6. At least 4 men and 1 woman. At least. So you're starting with 4 men, and then you will have 2 women. Hmm? At least. At least 4, at least 1. So you can have 2, right? And we have our next option 1, 2, 3, 4, 5, 6. The committee members have 6. So you could also have 1, 2, 3, 4, 5 men and 1 woman. Right? That's the next option. Could you have 6 men? No, because it must have. Work it out. And means the what? And you multiply or you add. Okay? Work it out and what you get. Right, let's see what you get. So that'll be 10C. Does the order matter? Well, it doesn't matter, right? 10C4 multiplied by 9 multiplied by 9C2. Then you're adding that to 10C5 multiplied by 9C1. When you add, you'll get a total. How much you end up with? What you have the first one? 2,200 and next one is what? 560. And last, how many are it? But I got the same answer. Yeah. Last one is what? Get up. No. Okay. Try next one. No man now. No man. Any other condition? How much for no man? 3 marks and 3 mark work. That don't make sense. Anyway. Work out no man now. Right, well, no man easy, right? No man would be 9C6. Right? That's the only option you have. How much is that? 84. That's it. Okay, next one. 84, right? Last one. By the committee that is chosen consists of 4 men and two women. The members of the committee randomly cue the members of the committee randomly cue for refreshments. Find the probability that women are not next to each other. Remember, it's a new committee, yeah? You're not considering 10 men and 9 women again. You go into this new committee here. The committee that is chosen consists of 4 men and 2 women. Find the probability that the women are not next to each other. So what's the easier thing to do? Find the probability when they're next to each other. Right? That's the easier thing to do. So you gotta work it out. So you gotta one individually pick out each one, right? Well, we can have it between that. So you gotta work out one option that is good. You really put out 4 men, 2 women. But same thing. That would be a really cool process. Remember the probability here? Yeah? Think about it. Remember it's a probability here. So you have to get a number in the event over the number in the sample space. So the sample space is how to get 4 men and 2 women. Right? So the number in the sample space is how to get 4 men and 2 women. That would have been 10C4 and 9C2. That is sample space. Right? Now you have to figure out within that sample space now, how many of them follow that condition. Right? So 4 men, and you treat the woman as 1. How many arrangements you have? You treat the woman as 1. Just 5. Well, you have n is 5. So would it be like 5 factorial over 4 factorial, or which is 5? Which is 5. So you only have 5 arrangements. Can you switch the women around? Did they talk about that? Nah, it don't matter. They didn't specify which one in front of. Yes, that's only 5. So probability is 5 over what was 10C4 9C2? 75. So it's 5 over 75 60. Wait, no. This one. Here's what it said. You already have 4 men and 2 women, and they said the members of this committee form a queue. Right? So that wrong. That wrong. So the probability, the probability of A is the number in A over the number in the sample space. The number in the sample space is just simply rearranging all of them, 6 factorial. Right? That's the total possible. Arranging all of them, treating them as different people, and arranging them. Remember, it's different people, right? It's 6 different people. How much is that? 6 factorial is how much? 7, 20. Right? So those 6 people could be rearranged like that, right? Right? And then the number in A will be that 720 minus when you keep them together. Right? So if you keep it 2 women together, remember which each person different. Each person different, they are not the same men, they are not identical men, right? Are you okay with that? Each one of the men different. Right? Each one of the men different. So when we treat them as one, when you treat the woman as one, each man different. So therefore it will be 5 factorial. Right? It's 5 factorial. So the 720 minus 5 factorial. Does it matter if the woman together? When the women together, we switch them around, it matters. Now in this case, right, they just want the probability of the woman and not next to each other. How much is that? What is that? Is it making sense? 600, like, let's go to one, let's make sure it makes sense, right? The committee chose that, they pick a committee already. How many people do they pick? 4 men and 2 women. So you pick 6 people. The members of those now could form a queue. How you can arrange that? And there's 6 different people. Right? We're not bothering with 10 and 9 again. Right? I made a mistake and choose them initially. So we have 6 people. And we can arrange those 6 people 6 factorial ways. That makes sense? No? So we know the number in the sample space. Find the probability that the women are not next to each other. So let's put the women together and minus the total. If we put the women together, we have 5 factorial. How much is 5 factorial? Right. Quick question. 5 factorial when the women together, right? But when you switch them around, and that will also be part of the committee, part of the queue. What was here? So you have Tom, Dick, Harry, Bob, right? And you have Jill and Francesca. That's one queue, right? But if you switch them around, different queue, so you had to multiply by 2. Because we interested when it's not together. 5 factorial multiplied by 2 is when it's together. Because there's 2 people that make a switch them and change it to 3. How much is that? 480. So I would say 480 on 720 is the answer. Right? We have to consider all the possible queues. Yeah, from one person. All right. The other tricky, well, I misinterpreted first. If you all read it properly, it's not a hard question. Next one. 21 had one, right? Twenty-one. 21. That's what we do when we do pay. Sure. The last part two, sorry. The last part two. The part one, two, and three. Right? I'm going to do part three is calculate the probability that a delegation will include exactly three footballers. Exactly three. Let's check out here now. So we have 4 athletes have to be chosen, 5 cricketers, 6 footballers, right? So 5 cricket people and 6 footballers. And I want a committee of 4 determine how many ways the selection could be made if there are no restrictions, right? So basically you have 11 people and they could choose 4. No matter, right? No matter what you choose. Right? You just want 4 athletes. How much is that? 350. The number of ways the selection can be made if a delegation must include at least 1 cricketer. So at least 1 cricketer means what? At least means 1 cricketer, 3 footballers, 2 cricketers, 2 footballers, 3 cricketers, 1 footballer, all cricketers. I have all the options. All the options, right? They're adding them and then they multiply, right? So 1 cricketer will mean 5C1 multiplied by 6C3. 5C2, 6C2. 5C3, 6C1. And then 5C4. Add them all up. 315. Finally correct. Or close to being correct. Then sure. That's good. All right, too bad. The last one is 4 seals. 4 seals. You get 275. So you get wrong then. Keeling get 100. She get wrong too. Don't forget the last one, 4 seals. 5C4. Oh. So 315. Yeah. 315, right? Last one, calculate the probability that the delegation excludes exactly 3 footballers, right? So A is 3 footballers, footballer, cricket. All over, what is total again? 3 what? Wait, no, no, no. Okay, wait, no, yeah. Oh, yeah. Yeah. So this would be how much was again? I forget. How much? 6. So it will be 6C3 multiplied by what 5 because 5C1. How much was that? 100. Okay, nice. So the probability of 10 on 33. Let's go to variables now. Take a 2-minute break. Let's go to variables. What are the two types of variables? Discrete and continuous. Okay. We didn't know that. Two types of variables, discrete and continuous, right? Take a 2-minute break. Two minutes, sir. Ready? Yeah. Let's go. So we're going to take a look at discrete variable. No integration, right? No integration, but you have to be able to find it on above. Take a look there. Let's take a look there and let's see. Let's do discrete first and then we'll continue. Right? The moment. All right. So we want to take a look at discrete data now. So discrete data, that's like whole numbers, of course. We know that because sum all the probabilities of something is discrete area one, right? It should be there how to find the expectation, right? You multiply x by all the probabilities, add it up. X squared, multiply x squared by all the probabilities and work it out. And these are the rules for expectation and variance. What is new to unit 2? What is new to unit 2 is when you have two variables, x and y. So the expectation of x plus y, you just work out e of x, e of y, and add it. Okay? And variance, same thing. Right? I want to show you the continuous part one time. Continuous, on the other hand, if I give you a continuous variable, you wouldn't get curves at this level, you'll get straight lines. If I give you a continuous variable, defined between A and B, then this entire area here is 1. Right? That entire area is 1. Okay? So the area underneath continuous random variable is equal to 1. Okay? The shapes that you will get will be trapezium and triangle. Right? No integration. Right, next we need to know about CDF and PDF. So when you're talking about continuous random variables, they have two types of variables they could give you. They could give you a cumulative distribution function, or they could give you a PDF, right? What did P stand for again? Probability density function. Okay. Probability density function. So if they give you a CDF and you want to go to PDF, they differentiate the CDF. If they give you a PDF and they want to go to CDF, that's cumulative, they integrate. All right? And well, there's a rule there for median. Okay, so we'll do a couple of those in a little while. Right? There are four distributions that we need to learn: uniform, geometric, Poisson, and, well, we can did one already, binomial. Those are the four distributions that we need to learn for discrete variable. For continuous variable, we need to mainly learn what's the variable for discrete. For continuous, the normal distribution, right? We are learning normal distribution. Right, that's going to the conditions for uniform. Remember, uniform and geometric are discrete. So a uniform distribution, each value is equally likely to occur. So it means that the probability are all the same. So if you get a distribution that looks like this, 1, 2, 3, 4, and each of the probabilities is the same, that is a uniform distribution. Right? Geometric distribution, very similar to binomial, except that keyword here. Trials needed for your full successful outcome. So for example, in a geometric distribution, you are trying to find out how many trials are needed before success. But in a binomial, you want to see how many success in all the trials. Okay, so a binomial might be something like that. You have 2 successes in 5 trials. For geometric, it might take 5 before you get a full success. Here, looking for the keywords, right? First. So a geometric written like that. This is the probability for geometric. Note that if you have P, Q is equal to 1 minus P. Right? Probability of, if I ask for the probability of X is less than or equal to 2, right? That will be 1 minus Q. Of whatever X is, X 2 in this case. Expectation 1 on P, variance Q on P squared. Okay, some questions simple, you know your distribution, sometimes you have to figure it out. Right? It's easy to figure out binomial because binomial is the same word I told you, right? Number of successful outcomes in any trials. And once you identify it's not a binomial, it's geometric. It's easy to identify uniform, all the problems are the same. And last one, Poisson is their average. So you get a mean over a particular interval. Right, by the way, to work on probabilities in binomial, you have to remember those 4 things. Right, you might remember that from unit 1. Right, you have to remember how to find the probability, expectation, variance. Poisson given by this. If I give you a Poisson, I'll give you a mean over a particular amount of time. And that's the way you work out expectation, probability, and variance. One thing you need to notice is that when n is very large, if n is large, then the probability is less than 0.1, then we can take a binomial and make it into a Poisson. Okay? That's only when n is large. So if you're doing a binomial and you find the n value bigger than 50 and p less than 0.1, you will have to convert it to Poisson. Right? And if the Poisson is too big, lambda is too big, right? Then we are using normal. And we have to apply continuity correction. Remember that? Remember continuity correction? When you're going from discrete to continuous, you have to apply them. All right, so it might make more sense to some people, but let's try and apply it now. because you have to kind of remember your normal distribution. Are you okay with that? Right. Just do my favor as a revision, and within your summary, just write out how to find the probability for a uniform geometric binomial puzzle. Just write the p parts. And in your summary, open and write it. And make sure you know the parameters before we start questions on it. Now, and then let's try a few, right? Ready? Let's start with 2023. Ready? 2020 with a 3. What we have here? One, we did one already, we did two already, we did, let's check out three. We did three A that's now, right? Oh no, we didn't, right. Take a little read, tell me what distribution you think we're going to use. Read it. Remember it's in the group here, or so if you're not seeing it, you can always go to the group on here. Think about it. What y'all think? What distribution you think of? Poisson, very good. So you got Poisson. Right? Keyword average. 3 months, right? By the way, if the question changes now, it says 6 months. What the lambda mean? Lambda will double, right? Nice. So the number of accidents occurring in a certain factory is modeled by a distribution, right? So X follows a Poisson with mean 1.5. Right? X follows a Poisson with mean 1.5. Find the probability that no accident will occur during the 3 months. So they want the probability of X is equal to 0. Right? They want the probability X equal to 0. Go to Poisson and work it out. I will need your help to work it out, right? What is that? 0.22. Right. Please remember, if we get something bigger than 1 and wrong, right? Right, Viv? If we get 500, go back to 500. And someday we'll go to probability and get more on. Yeah. I show 100%. 100%. Right, next one. Pay attention to the time interval. Double count. You get 0.22. Okay, next one. No more than 5, right? It's okay. Two killing. You got true? Right? You'll recognize that it have to change, right? How long the interval is now? How long the interval is? 1 year, right? The interval is 1 year. So X follows a Poisson. Now that is 1 year. It will be what? 1.5 by 4 and 6. So they want the probability that X is no more than 5. Are you working out that? That you gotta work out probability of what? 0. probability of 1, probability of 2. Wait, क्या do वाला? Yeah, we were probability of 3, probability of 4, probability of 5. You all know how to just change one value in the calculator. I just go back and change that value. So you want to go on Google, go type it back, you know exactly. Okay, then you get true. That's 10. That's the thing. Okay. Yeah, everything in this is one. Most of the guys where we do it. What's we taking this year? What is it? Right? What we got when you add it up? 0 point what? Huh? 6.5? One person gets 0.44. What do you get for this one? Remember, you have to change lambda from 1.5 to 6, huh? Yeah, why total value? 0.65. Huh? You work out 0 and 1 and 2 and 3, I think. Why you get 0? 0.0. And we had used formula 6 in it, right? Lambda is 6 now. What do you get for x equal to 0? How many days? Say answer wrong. Huh? Oh. 0.4456. What you get paid? X equals to 0, car. 0.002. Where you get paid? X equals to 1. 0.01. Okay, next point. Total. Well, I put the whole way around though. Okay. What do you get paid? X equals to 2. Point 0.04 and x equal to 3 is what? 0.09 and then you have 4 and 5, right? So I guess how you're wrong, we might change the values, right? Okay? I'm gonna make sure that you do it. Find the expectation during a 2-year period. What would it be? Expectation for person is lambda. Okay? So for a 2-year period is what? What would it be? Huh? 12? 12, right? 12. And the variance also what? For person, variance is what? It's also lambda. So therefore the variance will also be 12. Okay then? Let's go again. Same here have more, right? Take a read and make a distribution. What y'all think? Geo? Right? Because keyword is what? Keyword is until. Right? Until getting piece number 5 or more. Okay. So X follows a geo. It's a fair die, right? Yeah, it's a fair die. And I see that. 1/6. Wait, no. What's the probability of getting 5 or more? Right. 1, 2. 2 1. 2/16 or 1. Okay, so P is 1/3, that's the probability of getting 5 or more, and Q will be 2/3, 1 minus some. Huh? How I get the P? X, let X denote the number of independent rows of a 6-phase balanced diagram. Right? Means that 1 2 5 6 and phase. Until getting a number, getting a piece number 5 or more. So you have 6 pieces, right? So therefore you have 2 pieces more than 5 or more, 5 and 6. So the probability of getting that is 2 and 6. Find the expected value. Expectation is what for binomial? Huh? 1 over is 1 on 2/3, 1 on 1/3, which is 3. Right, so the expectation is 3. Find the last two parts. And the standard deviation and the problem. Right? Standard deviation. So in order for us to get standard deviation, what we need? Need variance. Nice. How you get variance? Q squared on P. Right? So that's what? 2/3 squared on 1/3. How much is that? So they get 4 and 3. Yeah, 4 and 3. So therefore, standard deviation is Q and P. Oh, sorry. I write it back. Sorry. Yeah, sorry about that. Q and P squared. Right? So Q was 2/3 all over 1/3 squared. So you got 6 or something? 12, well, 6 is variance. So standard deviation is √6. Then you want to find the probability between 2 and 6. Right? Remember, you're not including 2. So you can find the probability of x is less than or equal to 6 and minus the probability of x is, sorry, that should be less than. What you write here? Less than or equal to 2. Okay, you don't want 2 included, right? So this will include 6, 5, 4, 3, 2, 1. And this will include 2 sales. Take off that. And you'll be left with 6, 5, 4, 3. That's what you want here, right? 6, 5, 4, 3. Right? In the formula, work it out. Double count. Short. Right? Just go back to the table, right? The table has all the formulas that you can use. So this is 1 minus q to the power 6. This is 1 minus 2/3 to the power 2. The 1 will cancel that. What you end up with? 0.36. Let's go again. That was 23. This was 22. Right? So I tried to come around. Do it number 3. 3, right? Yeah, you're ignoring it. 3 and 4. Right? You're doing 3 and 4. So it's only group, right? So you don't want to wait to 3 and 4.
I'm just downstairs in group 5, right? So I have a kids. Anybody else commented to this one?
What's up?
This game?
Capacity.
Uh,
Oh, the whole level.
we gave it one.
No, closer. Only with a 1.
Then kids are even talking. Sure, it's there. Let's see the already game.
Not for the people. Right, we're doing 3, A, and we do all of 4, right? We do it here. One. Right on. It's 3 and number 4. What? Technical tree, 1, 2, 3. Yeah, because we all. Also, I'm doing the consider. The vertical division share. 0, 1, 2, 3. Plus one. Now, plus one, or sorry, the plus one. Huh? Is. Sorry, what's your name? Yes. Okay. Yeah, what's it be? Okay, and see. Yeah. Yes, I'm. He doesn't live for one of the lesson. So it's over individually. Geometrical that formula that allows it to. Oh. Hello? Hello? O hani gate dono ya vishnu dari pasta na past trip. Yeah, well, you got the line outside visual. Hold on. Oh yeah, that's where? Where was So like 11. Let's go now. Huh? All of a sudden, my mother took a bit from there. But we can't go that small. Like that. Where am I now? So what is right? And you look at. All right, let's correct this now. Yeah, because this was annoying. I think the way for unit, R is the unit one. So the time number up. Correct. Well, so that's it, right? 5% of batteries, but we don't think that's still right? 5% of batteries produced by a certain company and it's effective. On a particular day, batteries produced and inspected until the first defective batteries are encountered. That's geometric, right? Then X denotes the inspection number on which the first detected battery occurs, right? So X follows a geometric. What's the probability of the getting defective? 5%. Okay. Then they want you to find the probability. Right? Find the probability that the first defective battery occurs at the fifth inspection. So you want to find the probability of X is equal to 5. Okay? X equal to 5. So the formula for X equal to 5 is what? Q to the double thing again. Right, sorry. So the Q to the what? 5 minus 1, right? P. So that will be Q is what? I didn't work out Q. Q is 0.95. So it's 0.95 to the power of 4 multiplied by 0.05. Oh, you're not seeing all the way there. How much is that? 0.04. Yeah. Otherwise, that's geometric, right? Right? Next one. Determine the probability that within the first three inspections they get it. So they want the probability of x is less than or equal to 3. So that's 1 minus q. Right? X. How much you get it? How much? 2.14. 0.14, right? They ask for the expectation here. Expectation is what? 1 over 0.05, which is what? Assuming that the first 12 trials are free of defects, compute the probability that the first defective battery will occur at the 12th infection. Sorry, 20th. How you doing this? Assuming that the first 12 trials are free, compute the probability that the first defective I will move this up. H island jump. Create the excellent. I got it. Huh? Once it out and figure out why they put out full sentence. First 12 are free. Yes. Definition. Yeah, none of they had the last of the class. Yeah. Stop. Stop. No, no, no. Right, yeah, so based on what I'm seeing here, the same thing, right? Because of the first 12 are free, compute the problem to 20. You have to think about it. So the first 12. All the rest will be free. You can know this and the marks. Right, first time, the first time message on the group, right? So I'll look over this one. We had one for yesterday as well, right? But let's leave it at x equals 20. Okay, ask them for the I mean we'll get out tomorrow again. How much you got for x equals 20? Point. All right. Okay. I'm too sure about it. Right, with the consideration that we consider n to be different, start going to be different. 40. 40, so the marks of students in this year's midterm and final are reported, sorry, are represented by the independent random variables x and y. The combined mark T is x plus 0.5y. X and y are normal, they gave you the mean and they gave you the standard deviation. So they want the expectation of T. So you have to go back to your formulas, go back to the table. I think it's the beginning table. Again, go back to the beginning table and look for the expectation of x plus y. So it's x plus 0.5y. What will that be? Go back to the first thing under random variables under the screen. Yeah, investigate. Oh, I don't. What will that be? What will that be? That would be the E of x plus, right, 0.5 by E of y. And we already have E of x here. E of x is 28 plus 53. That's okay? So you don't need to know about the normal distribution or anything else here. Huh? E of x is the mean, yeah? E of x is the median. What's that? E of x is the mean. 74 point. 54.5. Okay, the next one is to find variance from, yeah, find the variance. Go back to the table and tell me what the formula would be for variance of T. Go back to the table and see if we can figure out what the variance of T will be. Right, tomorrow we'll do a few more types with it. Yeah, look at me. Standard deviation. So that's squared. But wait, tell me what the formula will look like. Variance of x plus 0.5 y is what? Variance of x plus what? 0.5 squared. 0.5 squared by the variance of y. Just leave it open or not? Yeah, we can leave it open. Right, so the variance will be 5.2 squared plus 0.5 squared by variance of y is 12.3 squared. And 2.7. Okay, that? Done. Oh wait, check away after that, Jude. Am I 0.5 squared? 0.5 squared, 12.3 squared, 5.2 squared. Point. 64.9. Did I two wrong there? I did that. 64.9. One more out there. Alright. Do you have any more on this? Right, let's just talk about it a little bit because we gotta remember how to do it normal, right? Same paper, part B. So the score X of the candidates on an aptitude test for enrollment at a certain university, normal distribution with mean 100, standard deviation 50. That's okay? Find the percentage of candidates who scored less than 80. So the only probability that X is less than 80. What you do? Standardize, right? So you want the probability of Z is less than. Go ahead, remember what to do. Go ahead. I'm just trying to help you, but I'll remember. Yeah. We have. I think so. We open everything. Okay. And then do our summary for them, right? Right, so you should have what, 80 minus 100 all over 50. That's the probability of C is what? Less than 1.33. Right, here's the problem though, when I'm out the table of they come in here, less than minus is here, that's here. Right? Less than minus 1.33 is the same as is the same as greater than, right? Which is 1 minus pi of 1.33. So go to the table and read off 1.33. Is 1.333 or 1.33? Okay, all right. So tell me what 1.333 as far as it go. Go to the table, there you go. How much? No, tell me what 1.33. Zero point nine one three. It's an arbitrary on the last value. So it's 0.9135 then.
Okay, 9087.
9087. And then when you minus the answer is what? 0.0013. Huh? Point 0.1912. Choose one guys at it. 0.191. 191. No, that's yeah.
It's 0.01.
0.0913.
0.
0.0913.
Right.
0.0913.
It is my paper, right?
Wait, no. What is the value from the table for 1.33?
0.9.
Right, now we're talking about 0.9. 0. Oh Lord, child, that's the table myself, wait.
9+9.
0.9. So when you minus, you get in what?
0.0913.
0, 9, 1,
Alright.
3.
Right. Right, and then they want to get the percentage candidate who score greater than 120. Same thing again, right? Same procedure again, right? Yeah. Right, so you standardize and you work it out, right? All right. All right, got it. So we'll stop there. Right, take a 10 minutes and then we start physics. Where you're going? Can you go to that next part? You finish at home. Right, so standardize and then work it out, right? All right, physics, online, you can log out. We've got to wait until physics, right? So since it's more than you work it out, it'll be here, 1 minus 5.